Okay, very good evening to all of you. So, I'm Professor Ashmi Bade, and we are going to start with soil mechanics of Prerna scheme. So, here you are having certain topics in your syllabus: origins of soil, soil structure and fabric, three-phase system and phase relationships, index properties, unified and Indian standard soil classification system. Since all these things have been studied in GT1, but now you are going to study again in this Prerna scheme. So here, soil mechanics is given by Professor R.G. Bade, Department of Civil Engineering, Anjuman College of Engineering and Technology, Nagpur. So what is the introduction? In introduction now, again I have given you what you have to study. So origin of soil, soil structure and fabric, three-phase system and phase relationships, index properties, unified and Indian standard soil classification system. So all this we have to study. In this some numericals will be there. So those numericals also we are going to study here online. So what is basically geotechnical engineering? We'll see it first. So what is soil? So soil is nothing but natural aggregates of grains, small particles, which may be loose, which may be dense, which may be moderately cohesive, inorganic, there may be chemicals or organic, fertile soil in nature that have the capacity of being separated by means of simple mechanical process. If you take some handful of soil and if you press it or just you break it, then it is broken into pieces by only mechanical process. So what is geotechnical engineering? A unique combination of science, experience, judgment, and a passion for understanding the uniqueness and variability of ground condition resulting from the forces of nature. It is very interesting subject. Unique combination of science. What does it mean, unique combination of science? Experience, judgment, and passion for understanding. It is very necessary that you should take keen interest in the subject. If you take keen interest in the subject, from science you get the results. When you do the experiment several times, you get the same result, then it gives you the experience that no, this is the result getting from the experimentation. So this is your experience. If you are calculating say bearing capacity of black cotton soil, you are getting it 100, 99, 100, 110, then you get an experience that the black cotton soil is having the safe bearing capacity from 80 to 120 to 150 only. So it is a soft soil. Judgment means from this science and experience you take one particular decision, and that is known as your judgment. And passion of understanding the uniqueness means you should have a keen interest in the subject and understanding. You should have a better understanding of that particular soil which you are going to learn. Variability of ground condition resulting from forces of nature. There are forces on the soil, those forces we have to study. Second is it is the art of determining the properties of unseen and variable materials to provide a facility that perform as expected at acceptable level of risk and at an optional cost. What is the condition? It says that if you are having a soil that is very harmful, then you have to remove it and you have to add non-cohesive soil. But that should be optional. Matlab, the cost of that particular risk should be very nominal. So what is next? Application of civil engineering to the earthen materials. So for earthen materials means what? What are the earthen materials for a civil engineer? There is one soil, another is rock, and another is groundwater. So these are the three earthen materials for a civil engineer to deal with, which comes in geotechnical engineering. Then what is the difference between soil and dirt? So you should know very clearly what is soil and what is dirt. That only you will be able to analyze the soil. So see what is written. If you can grow food in it, get paid to analyze it, or get college credit for paying with it, it's soil. Otherwise, it's dirt. It means that when you are having a soil, you are growing food in it, you are resting some structure in it, then it is a soil. But or otherwise, it is a dirt. Okay, it is a dirt, it is a dust. Then what is soil behavior introduction? So concrete and steel are textbook materials and soil is not. I think you agree with this because concrete and steel are textbook materials. What does it mean? From for concrete, if we get an example, you can have the IS codes and you can take the values from IS code. For example, if you are designing any structure by LSM method, limit state design method, then M15, M20, M30, they are defined. Okay. For steel also FE415, FE500, and steel structure, steel book is given to you. So these two, concrete and steel, are the textbook materials, but soil is not. You cannot say that safe bearing capacity of black cotton soil is so and so, sand is so and rock is so and so. You have to calculate it every time. Okay. So that's why you say that textbook material is not soil. They can be concrete, they can be steel, but soil is certainly different. Soil is very complex material. If you are changing one foot to another foot, from 1 meter if you are taking a soil sample and from 2 meter you are taking the soil sample, you are getting the two different values for that soil. So what is soil? Soil is heterogeneous. So soil is heterogeneous and soil is homogeneous. If soil particles are one and the same, then they are known as homogeneous. If soil particles are different, small, big, stones, etc., in that, then they can be said as heterogeneous soil particles. Then soil is non-conservative. Okay, if you see here, before you apply the load, the soil is like this. After you apply a little load, little pressure on the soil, it will try to compress. But if you release the load at an elastic value, then it will come to an original position. That means for very little load, soil is at elastic material also. That is known as your conservative soil material. But before, if the soil is like this, you apply larger load, then you remove the load, but the soil is compressed. How the load you have applied, the soil compressed, it won't come to its original position. Then it is known as soil as non-conservative material. But it doesn't mean that it's liberal. It's liberal means sometimes it may be elastic material, sometimes it may be plastic material. Then soil is non-linear. We can draw a stress strain curve by using UCS method. If you apply a small load, then it will be a straight line linear load. That means soil is not going to a plastic state. If you remove the load, it will come to its original position. But when you apply the load, it will try to change its position. It will be straight, then it will become curved, and then it will break down. When soil break down, it will come down. So it is non-linear material, plastic material. Then what is soil formation? So soil formation is by weathering action. Now see, there are four stages. If you can see, in first stage there is soil like this. There are no plantation. When you apply some plantation, the roots will be developed at very small linear stages. Then when these plants are growing, the roots are growing more, and the roots are forcing these soil particles in a downward direction. Again, when the trees are developed, the roots grow very, very fast in a downward direction, and they push their soil particles in a downward motion. So, what is soil formation? Weathering is the process of breaking down the rocks. So, these rocks are broken down into soil particles. Now you can see that the rocks have been developed into. In physical weathering, breakdown of rock is done, but it's made of stays the same. Made of stays made this. What does it mean? It means that their position of rock is same. They are broken into small rock pieces only.